I didn't record any of that. So there's 1, 2, 3, 4. Again. 5 and 6. Again. 7, 8, 9, 10. Again. And 11, 12, 13, 14. 14, of course, I did with Vx, even though no matter how you do it, you're going to get stuck with fractions. Jacob.
Can you go back to 7 and just do it? Because I think I got negative 2x plus 4. Because I took out the negative 2 and the 8x, so I should turn to a positive there.
What? No.
Yeah.
Oh, I see. Yeah. Yeah, that should be positive.
So then all should be positive, right?
So let me double check. I took out a negative 2, so yeah, it should be positive. So that should still be 16. So that's going to be positive 4. But then I put it at negative 4 anyway. So yeah, that should be a positive 4. But then I graphed it properly, so I don't know what the hell I was doing. And there's the rest. This, of course, like I say, no matter how you do it, you're going to end up with a fraction. Of course, you all would prefer decimals, so you're welcome to use them. I don't care. I've been trying to convince some of you for 3 years that fractions are easier to work with than decimals, and you still haven't changed over, so might as well just leave them as decimals. Which is the way I graphed it right here. All right. Wait, yeah. Okay, so we are on page 110, please, ladies and gentlemen. On page 110, we are coming up to the third way we have seen these. I would like to remind you of the first way was vertex form, which I showed you as this. But you have also seen written, this is the way I was taught it, but you have also seen it written as such. And the reason for that will become readily apparent in a moment. All right? But you all know what that is. That is your vertex X, and that is your vertex Y, and that is your stretch. And of course, what do I mean by that? X squared, or AX, and you go up AX squared. You all know that already. The second thing you saw yesterday was standard form. Y equals AX squared plus BX plus C. And once you had standard form, you had that was your y-intercept. And if you complete the square, you get vertex form. That's where we stand right now, right? Now, each of these things will tell you something just by looking at it. Both of them will tell you everything about a parabola if you manipulate them. All right? You all need to know the difference. Vertex form, standard form, and factor form are all the exact same thing. They've just been manipulated. All right? Because, of course, if I FOIL this, I get standard form. If I send the 2 in, I get standard form. If I complete the square on that 2, I get vertex form, yeah? Okay. Now remember how I said this would become readily apparent to you why they use H and K? Because the other way math teachers like to teach factored form of quadratics is they put a P and a Q here too. Now, you're smart kids. You know that if P shows up here and P shows up here, they should be the same thing, shouldn't they? So this should be the vertex X, shouldn't it? But it's not. I know, it's very frustrating. I was taught this, I was taught this. And then later on, math teachers figured out, wait a minute, we shouldn't do that to kids. And they brought H and K to this party. It doesn't matter, because you already know what this means, right? You know what does X equal here? -3 and 7. And those are, of course, roots. And by roots, we mean they are x-intercepts. And how do we find them? We find them when 0 equals x minus p and x minus q. Because x minus p would have to equal 0, or x minus q would have to equal 0. And we already know that, right? Right. Everybody good? Like up to right now, you haven't seen anything new. Actually, everything today isn't new. It's just going to be slightly more complicated. So when you see this guy right here, what can you automatically tell me right now just by looking at it? The x-intercepts. And what are they? -3, root 1, -3, and root 2, +1. Right? We know that our parabola has to pass through those points. What else do we know just from looking at that? How do you know it's a happy parabola? Because there's no negative a. So we also know it's going to be down here, right? Excellent. Now, from looking at this, we know a couple of things. We know where approximately the axis of symmetry has to be. Where is it? It's right in the middle of the two. So, and I'll do that in blue. The axis of symmetry, and the axis of symmetry, remember, is x equals something. And that, what letter haven't we used? We've used A, B, C, P, Q, H. X equals O. Sure. Yeah, you're right. That's no good. X equals D. Sure. That D is also our vertex X, right? And we know the axis of symmetry is right between those two, yes? So how do I find the value of something that's right between two numbers? What do I do? We did it last day. How do I find what? Pardon? I could count, right? That's easy to do, right? 1, 2, 3, 4. What's half of 4? 2. Okay, so I would need to go 2 away from each of them, which you can obviously know is -1, yes? But what happens if we have decimals? What happens if our one root is -7.3972 and the other one is positive 8.197? How would we tell the exact difference between -7.932 and 8.197? What's the exact distance What is the exact number between 4 and 6? What's the exact number between 4 and 6? 5. How did you know that? Because it's right in the middle. Okay, what's the exact number between 3 and 7? 5. Why is it 5? Okay, what's the exact number between 1 and 9? 'Still 5. So, how do you tell what is in the exact middle of two numbers? Matipus. Well, you add them, yes, because we're in grade 11. We don't plus things, but yes. Root 1 plus root 2 divided by 2 will equal our axis of symmetry. And of course, we did that last day, but that was a long time ago. So, all right. So, here, what is root 1? Negative 3. What is root 2? 1 divided by 2. What is negative 3 plus 1? What is negative 2 divided by 2? Negative 1. So our axis of symmetry is negative 1, which means our vertex must live somewhere on there, yes? Now you have two choices for where you put that vertex. 1, we could count. How far away is it from negative 3 to my axis of symmetry? 2. Is there an A value? No. So, when I move 2 on the X, how far do I move on the Y? 4, because it's X and X squared, right? So this would be down 4 from what? 0. So what is this point right here? Negative 1, negative 4, right? I could do it by counting. The other option is, now that I know that this is an X value, where can I put that number? Pardon me, Hayden? I can put it in the equation anywhere I see an X, right? What is negative 1 plus 3? 2. What is negative 1 minus 1? Negative 2. What is 2 times negative 2? And y equals 2 times negative 2, which is negative 4. And once I've confirmed it, I can graph it. Who makes the decision? You do. So let's look at the next one. Have the roots changed? No. I still have root 1 is negative 3, and I still have root 2, which is positive 1, and I know my axis of symmetry is right in the middle, still at negative 1, but what's changed? There's a stretch of 2. So when I go over 2, I should go down 4, but now that there's an A value, when I go over AX, I have to adjust up or down what? AX squared, right? So what is the x squared that I should adjust? 4. But I got to put the A in front of it, so I'm going to adjust. Say it loud, please, Ashton, so I don't want to stab a pen through my eye. Thank you. And is it going to be down 8 or up 8? Why? Because it's a happy parabola. So it is negative 1, negative 8, because of that stretch factor. Now, the next question is going to be a little weird. You will notice in the first two questions we had a negative root and a positive root, yes? And we know, and don't write this down please, we know that if we are doing the quadratic formula, because of that right there, that's what tells us we're going to have two roots, right? Now, normally when we see a positive or a negative, we mean positive or negative, right? And what's the borderline between positive and negative? 0, right? We're all cool with that, yeah? Okay. Look at this question. What are my roots? My roots are positive 4 and positive 6. So my new borderline now can't be 0, is it? What is the borderline? Pardon me? In this case, it's 5. But what do we call that line? The axis of symmetry. So when we're dealing with quadratics, and we know we're going to end up with two roots, right? The positive or negative roots means positive are to the right of the axis, and the negatives are to the left. So here I still have two different roots, but instead of 0 being the right and left deciding factor, it's the axis of symmetry. Everybody cool? What is the axis of symmetry? 5. Is this a happy parabola? So when I move 1 on the x-axis, how far do I move on the y? 1. Up or down? Down, because I want my parabola opening up. So how far is it from 4 to 5? So how far down do I go? 1. So what is that point right there? 5, -1. And can I graph it now with confidence? Yes. Now, of course, we can check. What's 5 minus 4? 1. What's 5 minus 6? -1. What's -1 times 1? -1. So we're right. Everybody good? Okay, now it's going to start getting weird. Really weird. What's strange in this one? -1/2. It's an A, right? So what does that tell us? It tells us two things. One, it tells us it's going to stretch. Is it going to stretch this way and get narrow and skinny, or this way and get wider and fatter? It's going to get wider, right? And since it's negative, are my hands in the right space right now? Is that what the graph's going to look like? Is it going to be sad? Okay. Does anything else change? What are our roots? So I still got a root at 4, and I still got a root at 6. And I still got an axis of symmetry where? 5. Now, 1 over to 5 means I should go up 1, shouldn't I? But how far am I going up? Half. So that is 5 and what? Half. And I'm going to stretch this way. Is everybody good to there? Okay, that's the first wrinkle I've thrown at you, right? That's the first thing that's been a little... We're good, yeah? Okay, what's weird about the next one? So when you look at that, you know one of the roots. What is it? What's the other root? This is the one you kids always screw up. What's the other root?
0.
Y. Not letter Y. Y is 0, the other root.
Because the only way you get y equals 0 is if the x and the y.
Right. All of you forget that. If I brought out your radical equations test, one of the final answers was 4x and x plus 2 equaled 0. And all of you got the -2, and 90% of you forgot that. 4x still has to equal 0. So in this case, we all know that x plus 2 has to equal 0, but often So often you all forget that x must also equal 0, because x has to equal y, right? So our other root is 0. Then from there you should be able to figure it out, yeah? What's the axis of symmetry? -1, right in the middle, because -2 plus 0 is -2. -2 divided by 2 is -1. Now, some kid always says, well, we've got a stretch factor. It's an A. Is it? No, that's an X. This is really X plus 0 and X plus 2, isn't it? Is there an A value? No. So is there any stretch? No. So when I go 1 on the x-axis, do I go up or down from there? Down, because it's a happy parabola. I went 1, so how far down do I go? 1. And what is that value right there? -1, -1. Any questions? Okay, so now let's have a look at that guy, because that guy shouldn't be a problem. You should have all the tools you need. What's the first thing that you find when you've got factored form? The roots. You know one of them just by looking. What is it? What's the other one? Positive 1/2. Is there anybody in the room that does not understand why this is 1/2? You have to tell me. Everyone is cool? Okay. How are we going to find the middle now? Because now counting is a little bit more difficult, isn't it? So we should probably add them together. What is root 1? -4 plus, what is root 2? 1/2 divided by what? 2. That's going to give me my axis of symmetry. What is it? This is tricky. -1 3/4. Or -1.75. Or -7/4. They are all the same thing. When I put that in here, that is my x value, yes? Now, Jacob, I've had a difficult weekend and a long day, first day back. I think you need to be the one to shut the door, because I cannot guarantee I won't go out there and... Thanks, buddy. And anybody you see in the hall, you should mark them and make sure that they know that they were just saved a lot of wrath. Thank you. Counting here is barfy, yes? Or is it? Is there an A value? No, there isn't, right? So when I go that way, it's x, and then my up or down is what? X squared, right? So how far is it from 4 to -1 3/4? If you had $4 and you spent $1.75 of it, what would you have left? How much? $2.25, right? So I went $2.25, didn't I? So how far down do I go? $2.25 squared, which is 5.0625. So what is my vertex? -1 3/4 and 5.0625, which is 8 thousandths. No, whatever. Who cares? You all would use your your calculators for this, right? And that's negative. And then I can do this. I know you want to count, But in reality, there's a lot more decimals than there are whole numbers, aren't there? And by relation, a lot more fractions than there are whole numbers, right? So you better understand this or its cousin, ax squared. Because if we're dealing with yucky numbers, we don't want to count, do we? Everybody cool? All right. So let's put all this together. This tells us, 1, it still gives us our A. A is still there. And A is reminding you right over here. Okay? This is A still. The second thing this tells us right away, our roots. Our roots are the opposite. Opposite P and Q. Why are they opposite? Because of that, damn it. Because of that negative sign. That negative sign means so much stuff. That's really one of the most difficult things in math. For you guys to remember that that symbol highlighted in green means so many things. It means move to the left. It means opposite. It means subtract. It is a complicated thing that we use there, and kids screw it up all the time, right? And that's really all this one tells us, doesn't it? But because we know number 3, or number 1 and 2, 3, our roots, not our rots, our roots will give us our axis of symmetry. Why? Because P plus Q divided by 2. Everyone's cool, yeah? Now, of course, when you turn the page over, as I always do, there's everything I just made you write down. Why do I make you write it down? Because brain research says that when you write it down, even in this day and age of typing everything into your cell phones, handwriting something down actually makes you remember it. So, here we have a quadratic function. Before I go any further, how do you know that that's a quadratic function? It's got a squared. Does it have to be an x squared? No. Could we graph this? Distance equals time squared plus 3 time minus 10. Could we still graph that? Of course we could. Now, if we wanted to graph that, looking at that, the only thing we know for sure is that point is going to be on the graph, don't we? Because we know the y-intercept from that, because it's in standard form, right? Do we know anything else? There's no stretch, right? Because there's no a value. If I want you to graph that, you'd have to do a table of values or change its form, yes? We can change its form in 2 ways. We can factor it, or we can complete the square. Is this a good candidate for completing the square? Why not? It's not a good number to divide by 2. So let's check for we can't complete the square. Is it a good candidate for negative b over 2a? Is it a good candidate for this move? Why again? Still going to give me a fraction. So we should try to factor it. Can we factor it? What does it factor to? X plus 5 and x minus 2, right? That's easy. What is root 1? Root 1 is negative 5. What's root 2? So I got root 1 out at negative 5, and I got root 2 at positive 2, yes? Now, is it a happy or sad parabola? Happy. And we know that it's got to go through here, yes? So is that going to be on the right or left of my axis of symmetry? It's going to be on the right of it, absolutely. How do I know where to put that axis of symmetry? It's down the middle of the 2. How do I find down the middle of the 2? 5 plus negative 2 is what? Divided by 2 is what? 1.5, right? Now, stop and think. What's happened here? 5 plus 2 is 3. 3 divided by 2 is 1.5. Is that in the middle? 1.5 is pretty darn close to 2, but it's a pretty long way from negative 5, isn't it? So have we done this right? Look again. This is an example of just following steps is going to screw you up, isn't it? Because it can't be that. So what do we got to do? It says to use P plus Q, right? Okay, so P plus Q are right there. Are these the numbers I should use? Or are these the numbers I should use? It's the actual roots, right? So what am I really going to write there? Negative 5 plus 2 over, which is negative 1.5. Now, does that make more sense? That puts me over here, 3.5 away from there, and 3.5 away from there, right? So we've got our axis of symmetry is at negative 1.5, which is also the x-coordinate of my vertex, yes? Now, what is my option for finding my vertex? 2 ways. I can use math. I went this way. How far? 3.5. From 5 to 1.5, right? So if I went this way, 3.5, is there any a value? So how far up? I have to go down, right? How far down do I go? 3.5 squared, which is what? You're going to need your calculator. It's fine. I don't expect you guys to know 3.5 squared in your head. 12.25. So this point right here is negative 1.5, negative 12.25. Now, does that make sense? Will that go through this negative 10 here? I'm on my way up. It will, won't it? Everybody cool? Now, what was my other option with 1.5? I could have brought it over here and plugged it into this equation, yes? Why do I not want to do that? It's just gross, right? Why not use this one calculation thing? But could you if that's what you're comfortable with? Who knows what you're comfortable with, me or you? You do. So I show you every way I can think to show you. You decide what works. So let's look at the next one. What do we want to do with that one? Some stuff we know right away. What do we know right away? Right? So it's got an a equals 2. So if I move that way, x, what is my adjustment? 2x squared. What else do I know just from looking at that? The y-intercept equals negative 3. So I can go ahead and put my dot right on there, right? So somehow the parabola is going through there. It's a happy parabola as well, isn't it? So I know it's got to go like that. Oops, that was stupid. It's got to go like that or like that, right? Has to. We're not going to draw because we don't know where yet. What would help us find if it's going to be the black one or the gray one? Factoring it or completing the square. Is it a good one for complete the square? I don't like it for complete the square. Why? Barf. So does it factor? Are there numbers that multiply to negative 6 and add to negative 1? Negative 3, positive 2, right? So x minus 3, but it's not really minus 3. 3 halves, yeah. And the other one would be x plus 2 over 2, which is x plus 1, yes? Now, normally, what would we do here if we were factoring? We'd slide this forward. Or we would use whatever method we like to use to factor. We would end up with 2x minus 3, yes? Do I need to do that here? No, because I only need the root, don't I? So can I leave this here? So what then is root 1? Positive 3 halves. Absolutely right. So there is root 1, and it's 3 halves. What is root 2? Right? Okay. So now we know we're at negative 1, and we know we're at positive 3 halves. Now we know it was this one on the right, right? How do I find my axis of symmetry? Okay, so what do I add?
Negative 1 and 1.5.
Why did I write 3 comma 2? 3 halves, you idiot. Okay. Divided by 2, right? What is negative 1 plus 3 halves? It is 1 half, yes? And what is 1 half divided by 2? 1/4, because we multiply by a half and we get 1/4, yes? So what is our axis of symmetry? 1/4, right? Now, again, this is tricky, right? How far do I go to get from negative 1 to positive 1/4? Yeah, see? Nobody likes this one. Yeah, it's 5/4, isn't it? Okay, so 5/4 is my x. So I square that to get what? 25 over 16. And then what do I got to do to that? Times 2 to get what? Yeah, 50 over 16 or 25 over 8. Right? Well, just wait a second. So 25 over 8 is 3 1/8, right? So, is it going to be positive or negative 3 1/8? It's got to be down here, right? Negative 25/8 or 3 1/8 or whatever, and then we draw. Now, Jacob says, wisely so, I don't like that. But was counting better? They're both kind of yucky, yeah? Sometimes you just got to deal with what's dealt to you. Is everybody cool? Yeah. Okay, I'm going to expect you to handle the next 4, but not right now. I want to talk about these next 2 things, because these next 2 things take the knowledge you already have, but pull stuff away from you. So let's look at this first one. I got it right here, yeah? So this is 4a1. I want to know the coordinates of that. Well, is that a root? I can quite plainly see it goes through the origin, yes? So I know it's what? My guess is 0, 0. What's this guy? 0b, right? Because I don't know. How can I find those roots? What can I do to that to find me the roots? Sure, you're right. It is actually. B0. What do I do to that to find roots? That's y equals 2x squared minus 12x. I want roots, so what do I make y? 0. And what should I do to that? What did I do to that to get roots? To that to get roots. Factor. So what should I do to that to get roots? Factor. What's coming out? 2x, and what's staying in? Minus 6. So one of my x's is 0. I already knew that. What's the other x? So this is really 6, 0. Right? All we're doing is factoring. It just looks different. Okay? So B. This is something that professors and teachers and things like to do to mess with your heads. Write down the equation of the axis of symmetry. What is the axis of symmetry? Has to be 3, right? Why? The vertex x equals root 1 plus root 2 divided by 2, right? Right? 0 plus 6 divided by 2 is 3. Is that the equation? No, that's just the vertex x value. How do I make it the equation? X equals 3, because that is the equation of that line. Everybody cool? That's why I have it here as an exam-style question. That's the type of thing teachers and profs put on an exam to make sure you know what's really going on. In reality, what's the number that's important, or what is important there? The 3. This is important when? In math class. Everybody cool? And sadly, you're still in math classes, so that's important. Everybody good? Okay. And finally, for C, how do I find the vertex? I've got 2 choices. What are they? Okay, how far is that? 3. So I went 3 on the x. How far down did I need to go? How much? 18. Why? Because I got a 2 there. This is 2 times x squared, which is 2 times 3 squared, which is 2 times 9, which is 2 times 9, which is 18. And since I had to drop, it had to be negative. So the vertex is 3, negative 18. Is everybody cool? Okay. Now, the next one I'm also going to work through with you before I let you free. But I have to remind you of something. Put down your pencils. You don't need them. This is grade 10. If I write this, what I'm about to show you is grade 10. If I write this, you know what it means, yes? Everybody remembers? So if I wrote this, what does that mean? X equals 2, so what would I write here? 2 times 2 minus 3, right? And the answer would be what? 1. Good? Easy peasy, right? Okay. If I wanted another equation on the same graph, could I call that second equation f of x? No, why not? Because f of x is already taken up over here, yeah? So I got to change its name. So I give it a different letter. Everybody cool? Everybody remembers this? G of x is x squared minus 1. Still cool? Okay. So what then would be the g of 3? That would be 3 squared minus 1, which would be 8. Is everybody cool? Okay. What then would the f of the g of x be? No, just stop and think for a sec. You can do it. Allie.
2 times x squared minus 1 minus.
Absolutely correct. Because we need the function, the f function, when our x value is the g of x. Is everybody cool? Now, this is yucky to look at for math guys. Math guys don't like this. So there's another way we write this. This is called a composite function, because you have the first function, and then you run that first function through a second function. Now, sometimes kids find this easier if I were to write this. The f of the g of 2. What do you do here? You put 2 in there, right? Actually, let's use 3 because we just did the g of 3. So the g of 3 is what? 8. So this becomes the f of 8. And then that would go up here, 2 times 8 minus 3. Everybody good? Okay. Yeah, everybody likes working with numbers better than they like working with letters. Unfortunately, there's an infinite amount of numbers, so it makes it hard. So this right here is written a different way. This is how I write it to teach you, because this makes sense once we talk about it. The way we write this properly in math is this. F with an open dot. It's not an O, and it's not a closed dot, because a closed dot means multiply, yes? It's F G X. And yes, Jacob, that is how they say it. Fog X. Now, if I wanted to reverse it, and I wanted the G of the F of X, this would be Goth X. And math guys do spell it. Everybody cool? So all that means is that. Everybody okay? Nothing new. Everybody in my classroom did that last year. I just didn't tell you what it was properly called. So let's slide back to where we're working. This is the last thing I'm going to do with you. And then I'm going to let you do your 4. And there's one other thing I want you to do, but you're going to have lots of time to do it, like 25 minutes. So here is a function, yes? Here is a function, yes? I want the fog of x. So let's write that out. I want the f of what? Of the g of x, right? So I want the f. What is g of x? X minus 2. Which means I now need to go to which function, yellow or green, when I'm dealing with the f? Yellow. And I need what squared? X minus 2 squared plus 3, yes? Now, if I stop right there, can I write the coordinates of that vertex from that? Isn't that vertex form? Great. So there's A. What's the coordinates of that vertex? Vertex equals what? 2, 3. Everyone agrees? Okay. Keep reading. I'm going to make a third function. That third function is function h. This vertex, the vertex of h, is what? Read the question. What's important in that sentence? Right. So this vertex is going to move 5 in the positive x's. So what is my new vertex going to be? 7 and 1. Does everybody see why? There is my 5 units positive. And there is my 2 units negative. So that covers B. So now I have a new vertex, yes? How do I write? What form can I write right now? Vertex form, which is y equals what? Do I want that form? What do I want? Standard form. So what do I have to do? Jacob, this is your bread and butter, man. Expand! So what is it? So there's C, and what's D? Everybody good? Was there anything new in that? No, I just threw in some different words. Translate. I didn't say right or left and up and down. What did I use? Positive direction and negative direction. But we already know on a graph what's positive. Right or, and what's negative? Down or left. Right? Nothing new. Your work for now, and you have 25 minutes with which to do so. I left you 4 questions. Now please notice, complete the square or no? Complete the square or no? Barf. Complete the square or no? Yeah. Complete the square or no? Complete the square or no? But aren't they all also factorable? So your choice, right? What should you be practicing on this section? The factoring one, right? But do I care? No. But the other thing I want you to do is, in your own words, fill in page 114. What you know from each section. I know you've already got it in your book. I know we've already done this. But I want you to put it all on one page. And then when we get to the review of this section, and I have those pages where I say test review, we will write in big letters, page 114. Because this is going to have a bunch of your review on it. Everybody good? Go diddly-o. Look at the next thing. What is it? Quiz. Will we have that quiz tomorrow? Possibly after we've gone over this, depending on how well that goes. Right? If these 4 questions, you guys come back, oh yeah. Huh? Well, then I guess you're going to have trouble on the quiz if we were to have it tomorrow. All right? Go.